Draw a graph showing the variation of binding energy per nucleon with a vast number of different nuclei. Write any two salient features of the curve. How does this curve explain the release of energy both in the process of nuclear fission and fusion? We'll see the graph first. The variation of the binding energy per nucleon with vast number of different nuclei. See, this is the variation of the binding energy for different nuclei. Okay. Here the hydrogen atoms are there, iron atoms are there. Okay. So here the x-axis indicates the mass number, that is A, and the y-axis indicates the binding energy per nucleon. Okay. Helium, lithium, nitrogen, carbon, oxygen, sulfur, sodium, all the atoms of different new binding energy we can see in this graph. Okay. And the two silent features of the curve are, first one, the binding energy per nucleon is practically constant, that is independent of the atomic number for nuclei of middle mass number. Okay. That means here the mass number A, it is greater than 30 and less than 70. Okay. For example, here the maximum binding energy, it is iron. Here it is the maximum number. Okay. Second point is the binding energy per nucleon is lower for both light nuclei A less than 30 and heavy nuclei A greater than 170. Okay. And for the fission, we can say that very heavy nucleus has a lower binding energy per nucleon, will undergo fission and split into two medium-sized nuclei with large binding energy per nucleon and release a tremendous amount of energy. Fission process. Okay. And for the fusion, when two very light nuclei having low binding energy per nucleon combine together and form a medium-sized nuclei of higher binding energy per nucleon, releases enormous amount of energy in fusion process.